Hello guys, welcome to the second part of the demo of the mMath library. In this second part we are going to create a Stretchy IK setup using the library. So it's a more hands-on example, and an example that a lot of you might relate with because you did that already with regular mel or Python. Okay? So the setup we have is really simple. It's just a simple IK, and we use an end driver to drive the IK, a start driver to drive the base of the chain, and a pole vector, okay, to drive the elbow position, basically orientation. So you see the setup is really simple: pole vector and start and the join chain. Okay, so let's get started with the setup, and let's pop up the node editor so we can actually see what we are doing there. Okay. So first things, we need to declare an array. We declare an array with all the joins. If you're into a bigger script, you have this variable already because probably you created a bone yourself, so you already have this list. But in this case, this is a standalone example. I need to create the array myself. Okay, so join 1, join 2, and join 3. Then we declare the vectors. So in this case, n vector, because we are going to work with nodes. One for the start driver, one for the end driver, and one for the pole vector. Okay, so we declare all three. And we also declare a scalar attribute, sorry, a scalar vector, sorry, or just a scalar class, sorry, for the stretch attribute, which actually is on the end driver. You can see that. So basically we use that attribute to drive the stretch, so to say how much stretch we want. So we declare the stretch value as well, and now we can get started. So first things, we want to know the distance between the shoulder and the wrist, or the base of the leg and the ankle, or basically the base of the chain and the end of the chain. And that's a simple vector subtraction. So we're going to make a subtraction here. There we go. And then we want to know how long is that vector. So we just call the vector length on the result. So in distant value we call the length method. Okay. So that's the first step. Next, we need to know how long is the chain not stretched, okay, or compressed. So to do so, one of the trick is to just get the translate x value, and that's what we're going to do. So the up length is going to be the translate value x value on the elbow, and the low length is the x value on the wrist. Okay, so now we have that, and we are going to create two scalars for those two values. Okay, so the nScalar class has a method called fromValue that's allow you to create a scalar class from a fixed value. And what is going to happen is that it will create a node, create an attribute, and store the value on that attribute, and create an instance with that attribute. Okay, so basically we can store this value somewhere and use that to wire up in our setup. So let's actually see that happening. So we call nScalar fromValue, passing the up length value. We see the nodes get created, and we have an up length fromValue attribute. The same is going to happen for the low length here. Okay, then we want to know the total initial length. So we are just going to sum the two vectors we created, so they are summed together. And then we need to know the ratio between the two, so the current length and the initial length, and we just call the division operator between the length, which is the vector we created before, and the initial length, the one we just created before, right now, sorry. So we do the ratio between the two, and then what we're going to do, we are going to multiply the initial values, the initial length of our bones, for the ratio. Okay, so we do that for the first one, we do that for the second one. Here we go. So now basically we have our scale value for our bone. What we are going to do next is we are going to blend those two attributes, okay, because we have the scalar here and we have the normal one here. but we want to blend that based on the stretch value. So we call the blend method for the scale up and scale low. Okay? So we are going to blend those two attributes. We see then here. So we see basically we are blending. Let's see that in the low one. So we are blending the two results with a blend node using the stretch value as a driver. Okay? So we see here we did a bit of vector math, and then it's mostly scalar operation, which works exactly the same way. So you can see the interface with the classer for scalar and vector is pretty much the same, because at the end of the day a scalar in this case is nothing more than a vector of length 1, sorry, with size 1, so with just one value, instead compared to a vector 3 like a translate. Okay, so now we have our blend distance. What we need to do, we want to use this value only if is longer, but sorry, if the stretch is actually happening, because if we are compressing, we don't want to squash the chain. So we are going to create a condition node, and this is going to be done in the old-fashioned way. So we create a condition node. We use the connect to of the ratio for the first term. We set the second term to 1. So basically we are saying if the ratio is bigger than 1, we are going to do something. Okay? So basically if the chain is stretched, we're going to do something. And then we set the operation to 3, which, if I recall correctly, is the greater or equal. Yes, exactly so. Greater or equal. So if our stretch ratio of the stretch is bigger or is bigger or equal than 1, we are going to do something. Okay? So now we are going to connect our final upscale vector to color if true, or we are going to use the initial length connected to the color if false. And we do that also for the low, connecting that to the G value. So we use the R already, and we are going to use the G value. Alright? So now this condition node in the out color R and G has our final length that we want to connect. So we are going to connect that directly. Okay, so you see we use the condition out color to translate text of both bones. Okay, so here we go. Let's move our bones here, and here we go. So I'm not going into too much detail about why we do all this operation, because that's not a rigging tutorial, but that's a way for doing this kind of setup. So if we see the result here, you can see if we stretch now, our chain is going to stretch. Okay, let's undo that. And you can see we did that in really few line of codes. Okay, if you remove the comments, it's like 20 line of codes, something like that. So it's really you see you can do that really easily with really few code, compared to create all the nodes manually and do all our stuff. And you can see also it's really easy to read, because it's really like math operation. Okay, so it's really easy to see what I'm doing here. Okay, I'm summing two values rather than see create plus minus average, connect the values, give a name to the node, and so on. It's really easy to read, so it has a high readability. Okay, so that's it for this example. The next one we are going to make a more advanced Stretchy IK, where basically we're also going to lock the vector, the elbow to the pole vector if you want to. Okay, so see ya in the next demo.